Hi guys. Okay, until we get the glitches worked out on Teams, I'm gonna do these tapes. So when you look at this right here, you can't add those together because the denominators are not the same. We can only add fractions if the denominators are the same. So what we have to do is make the denominators the same. So if we take the 3 and we do the multiples of 3, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and we could keep on going, okay? But let's go to this one, 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, dot, dot, dot. We don't have to put a lot down. It's really just till you get one that's the common denominator. So you have to go over to the number that is in both rows, and we see that both rows have 12 in them first, 12. Now if we kept going, we'd get other common denominators, or common multiples, I should say. But we're going to use 12. Remember, we always want to use the smallest number that we can. So we are going to make these common denominators 12. Well, we're in luck in that 8 twelfths is already in twelfths. So we just have to move that back over. 8 twelfths equals 8 twelfths. 2/3 is what we have to change. So 2/3, you're going to write 2/3. So for instance, over here, what I did is what I wrote up here was 2/3 equals, and then I put a 12 in the denominator, okay? Because that's what we've decided to use is 12. So then to find this missing space right here, the numerator, we just come down here and we use our multiplication chart if we need to. 3 times what equals 12? Well, we know that 3 times 4 equals 12. So now it's easy to find this because we follow our rule that whatever we do to the bottom, we have to do to the top. So 2 times 4 is 8. Okay? So that's how we got 8 twelfths. Okay? So now that the denominators are the same, we can add, but we don't add the numerators. We keep the numerator 12. I'm sorry, we don't add the denominators. I'm sorry, oh my goodness. See, the bottom number is 12. We don't add those. We just keep the denominator 12. Now we do add the numerators. So 8 plus 8 is 16. So 8 twelfths plus 8 twelfths is 16 twelfths. Well, the thing with this is that this is an improper fraction because the numerator is bigger than the denominator. So that's a division problem. So we write 16 divided by 12. We read it from top to bottom. 16, this is a division sign, divided by 12. So we're going to write it in the box like we know how to do from previous years when we're taught. So 16 divided by 12. So how many 12s are in 16? Just one. 1 times 12 is 12. 6 take away 2 is 4. So the 4 becomes our new numerator. This is what's left over. And we keep the denominator 12 the same. See? This is the denominator. So your answer here is 1 and 4 twelfths. Okay? All right. So let's do another one. Okay? So I'm going to erase that and do another one. So let me remember how to erase. There we go. All right. So now, this is being taped, so you can always look back at it, okay? So let's look at number 2. 3/7 plus 2/5. So we have to make these denominators the same, okay? So we could do the multiples of 7, 7, 14, 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. And we could keep going, but we don't have to do a lot of numbers. Okay, now let's do the multiples of 5. So we're going to count by 5. 5, 10, 15, 20, 25, 30, 35. Oh, I think we've come to a common multiple. You see that? 35 and 35. That is a number that's in the same, the least common multiple, okay? It's the lowest one. We always want to work with as low a number as we can. Another way you could have done this, as long as you don't get too big a number, is you could have just multiplied those two together. 7 times 5 is 35, okay? All right, so now we can add those fractions because the denominators are the same. We have made equivalent fractions, okay? So now this is easy to solve if you just remember to come here and go 7 times what is 35. You can use your multiplication chart. You could do division, 35 divided by 7, and you find out that 7 times 5 equals 35, okay? Now, you know our rule that whatever you do to the bottom, you need to do to the top. So if we multiplied the bottom by 5, then we can go, oops, oh no, I don't know why it did that, rats. Oh, rats, rats, rats. Okay. Oh my goodness. So we had 35 as the denominator. 7 times 5 is 35. And whatever we do to the bottom, we have to do to the top. So 3 times 5, and there's your missing number there. That's how we find it. And then we come down here, and we have found 35 to be the common denominator. So now we just have to go 5 times what is 35? You know that 5 times 7 is 35. And we know the rule that whatever we do to the bottom, we have to do to the top. So now we know this. 2 times 7 is what? 14. All right, so now when we add them together, we keep the bottom number, the denominator, the same. We don't add the denominators together. We're adding here, okay? All right, now we are going to add the numerators, or the top numbers. So 5 plus 4 is 9. 1 plus 1 is 2. So this is fine, a proper fraction. This is a proper fraction because the top number is smaller than the bottom number. So this is our answer right here. So we're going to come over here and do 29 over 35. Okay? All right. I hope that's getting a little easier. Let's go and do another one. All right, 7/8 plus 56. So what I always do is rewrite it so that they're on top. They're vertical instead of horizontal. That's the easiest thing to do, is to rewrite it instead of writing it like this. Okay? Equals. All right. What's our first step? We have to say to ourselves, can we add these two fractions the way they are? And we know that we can't, because when you add fractions, the denominators must be the same. And if they aren't the same, you have to make them the same. And we do that with multiples. And multiples is just you're multiplying 8 times 1, 8 times 2, 8 times 3, 8 times 4. You're skip counting. 8 times 5, 1, 2, 3, 4, oops, 32. 8 times 5, and 8 times 6. Okay? All right. And we could keep going. Then we come out down here to the 6's. 6 times 1, 6 times 2, 6 times 3, 6 times 4. Wait a minute, 6 times 2, 6 times, wait a minute, oh, what am I doing? Goodness sakes. Oh, look at that. 6 times 2, 6 times 3 is 18. Oh, I really jumped ahead, didn't I? Goodness. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. And 6 times 8 is 48. And there's our common multiple. And again, when you get more practice with this, you'll know that you can just do 8 times 6 to get a common denominator. Because if you're doing 8 times 6, 8 will go into it 6 times, and 6 will go into it 8 times. So 48 is your common denominator. The reason that I keep stressing multiples is because sometimes when you multiply these two together, you'll get too big a number. And remember, we want to work in small numbers if we can. So the actual lowest common multiple might be smaller if you get a real big number here. That's why I'm teaching you about multiples, okay? Yes, this works, but if it didn't work and you got too big a number, you need to know to go by multiples, okay? All right, so once you have the common multiple and you have a common denominator, you can add them. You just have to know that when you get this, let's see, when you get this, we're running together, so I want to make sure. You have to solve for this missing space, and you can do that. You just come down here and you say to yourself, 8 times what is 48? Now, you can always, remember, multiplication and division are interrelated. If you did 48 divided by 8, you would get this number. If you know your multiplication facts or you can find it on a chart, you can get this number. So 8 times 6 equals 48. Now that you have this, you can do this, because the rule is whatever you do to the bottom, you do to the top. So 7 times 6, if you look at your multiplication chart or a calculator, you get 42. Okay? So now you've answered this and got the missing number here. So now you have to come down here and get the missing numerator here. And you can do that. Just look at this one. 6 times what is 48? You know that 6 times 8 is 48. And you know the rule that whatever you did to the bottom, you have to do to the top. So 5 times 8 is what? 40. All right? So now we can add these two. Oopsie. Add those two. So when you add those together, and the reason you can add these is because the denominators are the same. So we're going to keep the denominator 48. We don't add those together. You don't add the 48s together. You keep 48 and you add 42 plus 40. 2 plus 0 is 2. 4 plus 4 is 8. So This is an improper fraction because the numerator is bigger than the denominator. So that's a division problem. 82 divided by 48. So 82 divided by 48. 48 will go into 82. Oopsie, that's an 8. Let's see, one time. So, and remember, this is sometimes guess and check. The reason that I know it's 1, because if I did 48 times 2, I will get 96. And 90, oh, no, it's going to go. Oh, my goodness. Don't go. Don't go. Oh, good. 96. And we know that 96 is bigger than 82. So this is a 1. 1 times 48 is 48. And now we have to subtract. We cannot take 8 from 2. So we have to borrow from the 8 and make this a 7. Make this a 12. 12 take away 8 is 4. 7 take away 4 is 3. All right, so that 34 becomes the new numerator. I'm going to change the color so it doesn't go into this. 34, oh, that's not much. 34 over, and this is the denominator, 48. So your answer there is 1/34/48. All right, so 1, what did it do? Oh, I don't know what it did. Oh my goodness, now go back, that's too big. Oh my goodness sakes. Oh, this is so sensitive. So this one is 1/34 48. Okay. All right. So I hope that's a little clearer now. So let me see if I can go back. Go back. Oh my goodness. I don't know what it did. Oh my goodness. All right. So, all right, let me erase this. All right. So I think you have the idea now, and I'm going to give you a little help with a couple more, and then I'm going to leave a couple for you to do on your own. So these two denominators are not the same, so we have to make them the same. So we know that our multiples of 2 are 2, 4. Well, look at that. We don't even have to go any further because here's 4. So our multiples of 4 are 4, 8. Well, look, we've already got our match, 4. So when we go to do this, we can keep, and remember, you're going to write them up and down because it's just easier instead of across. So you're going to have 1/4, and then you're going to change 1/2 to 4ths. Remember how to do that? You make this a 4, and then you know how to do the rest. 2 times what is 4? 2 times 2, you can use your multiplication chart or a calculator. So you know that whatever you do to the bottom, you have to do to the top. And 1 times 2 is 2. So 1/2 is 2/4. And then you keep your 1/4 and you add them together and get an answer. Okay? Remember, you don't add the denominators. So your denominator is just going to stay 4, but you are going to add the 2 and the 1. So you should end up with 3/4 for your answer. All right. Okay, here's an example of, All right, well, actually, here's an example as well. If you had done 4 times 2, you would have gotten 8. But then you would have had to change the 1/4 to 8ths. That's why we use the multiples, okay? If you do 10 times 4, you get 40, which will work, but there's actually a smaller one that will work. If you do the multiples of 10, you get 10, 20, whoop, oh my goodness, 20, oh dear, 30, and 40, okay, dot, dot, dot. Oh, okay. Now let's do the multiples of 4. 4 times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20. So look, we don't have to use the bigger number 40 because we can see that this, and it's messy, but this is 20, and here's a 20. So we want to use as small a number as we can. Yes, would it work if we use 40? Yes, but we really want to try and do as small a number as we can. So if we change 9/10 to 20, 9/10, and we change it to 20, all we have to do, once we do that, 10 times what is 20? Times 2. And so whatever we do to the bottom, we have to do to the top, and we get 18. So 9/10 is the same as 18/20. Now let's change 3/4 to 20s. 3/4. Oh, I bet I could have zoomed in there. 3/4 equals 20. So we can do this. We say 4 times what is 20? 4 times 5, right? So we can now do the top one. 3 times 5 is 15. So now we've got this is plus, and we know that 3/4 is equal to 15/20. All right, so when we add these together, we get 20, don't add the denominators, 20, but you do add the numerators, and 15 plus 18 is 33, okay? Now I know that Mr. Gregory wants you to reduce these if they're improper fractions. Do you remember what an improper fraction is? An improper fraction is when the numerator, the top number, is bigger than the denominator, and it's a division problem. So we say 33 divided by 20. How many 20s are in 33? 1. We know that because 20 times 2 is 40, and 40 is too big here. So we get 1 times 20 is 20, and then we subtract, and we get 13, and then this is the denominator. So 1 and 13 20s. Okay, so your answer in here is going to be 1 and 13 20s. Okay? All right, now let me see if I can zoom out here. See if it'll let me zoom out. It always comes up when I don't want it. Now it's not going to come up because I want it to. All right, so I need to zoom out so we can see the rest of the page. It's not going to let me. All right. All right, I don't know even if there's 8 problems or 10, because I can't zoom out. Oh, here, I know what I can do. I can erase all of this now, and you have it on tape if you need to go back to it. So I think I can erase. Oh, there we go. There we go. Okay, so we have done 5, okay? So, oh, how many do you have? 14. Okay. So, okay, let's look at these. I'm going to give you a hint on a couple more, and then I'm going to leave some for you to do on your own. So, if you look at the 6 and the 3, and you think about the multiples, so, where's the color? Is this? Okay. Okay. So, oopsie. Okay, so if you do the multiples of 3, and you get 3 times 1 is 3, and 3 times 2 is 6, right there you've got a common multiple. So you're just going to, when you add these, make this 5, 6, keep it 5, 6, because you can use the denominator 6. And then you're going to change 2/3 to 6. Okay? And then you're going to add the numerators. All right? So down here, you can't use the 7 with the 2 because that's odd. But if you multiply these two together, and this is a case where this will work, and you do 2 times 7, you get 14. So 14 is going to be your denominator. So here you have to change 1/2 to 14s. Or didn't that work? Oh, no, don't. Oh, wait. You're going to change 1/2. Now it's going to go wacky on me. I don't know why. Equals 14, because we decided that that's the common denominator. All right. And then you're going to change 4/7 to 14ths. Oops. Equals. I don't know why it's doing this. Oh my goodness. Oh, all right. So you're going to change 1/2 to 14ths, and 4/7 to 14ths, and then add them. Okay. So I've given you a hint on this one. The denominator is 14. Change 1/2 to 14ths. Change 4/7 to 14ths. I've given you a hint on this one that the denominator is 6. So you're going to have to change 2/3 to 6 and then add the numerators. Down here, if you count by 5s or do the multiples of 5, you'll get to 10. So you can use 10. So you're going to change 3/5 to 10ths. You're going to keep the 7/10ths and then find out how many tenths 3/5 is. Now, down here, we are going to be able to multiply here. 3 times 4 is 12. So your denominator is going to be 12. And so you have to change 3/4 to 12s, and then 1/3 to 12s, and then add them. Okay? Over here, all right, here's an example of 9 times 6 is 54. Now, you could use 54. You can. But I think we get a smaller one if we do the multiples. 9 times 1 is 9. 9 times 2 is 18. Dot, dot, dot. That means we can keep going. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. So you see, we can use the smaller number 18 rather than the big number 54. Now, you will still get an answer, but it won't be in lowest terms. And it's always best, if we can, to work with the smallest number that we can. So on this one, you're going to change 2/9 to 1/18. You're going to change 5/6 to 1/18. And then you're going to add them together. Keep the denominator 18. All right. All right. Okay, I'm going to do one more hint, and then I'm going to leave these last three for you to do on your own. So here's another example. If you multiply these two together, you will get a big number of 108. Okay, that's going to be a big number to work with. So this is where it's going to be easiest to do your multiples. So 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. Now, let's look at 12s. And the better you get at doing your multiplication facts, the more you're going to see this yourself. So 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. So see, we can use 36. 36 is going to be an easier number to use than 108. That's why we use multiples. So your denominator here is going to be 36. So you're going to have to change 5/9 to 36, and you know how to do this, guys, now. Equals 36. 9 times what is 36? So whatever you do to the bottom, you have to do to the top. Okay? 5 times 4 is 20. So you're going to change that to 36. You're going to change 11/12 to 36. Then add the numerators, but keep the denominator 36. All right, I hope that helps. Then I'm going to go ahead and let you do these last three on your own, just for the practice of independent practice for you. Okay? All right, if you have any questions, let me know. I hope this helps. We'll see you tomorrow.